traveling around to a bunch of the Oracle Code events worldwide. We've done these across the US, Europe, and now Asia. We just finished Oracle Code Japan, which was an awesome event. We're on a motorcycle tour following that event, traveling across Japan, visiting different user groups. The reason why Oracle's reaching out to developers is the way people buy software, services, and products has really changed. Now, developers have a lot more control over the technologies they use, so we want to directly engage with developers, teach them about some new open source technologies, and then show them that those technologies which we're using run very well on the Oracle Cloud. One of the big advantages Oracle has is having a very large community. So by building on top of our stack, you're not only getting the Oracle products and services which run on our cloud technology, but you're also getting a lot of community support from folks in those open source technology communities. So there's over 300 Java user groups globally, Java user groups and the Oracle user groups. They run their own events, they talk about technologies, they help folks get up to speed on how they can use our cloud technologies and platforms, and you can be part of the community. Basically, we're traveling across Japan and stopping at a dozen user groups in between via motorcycle. So it's a very efficient way to hit up a bunch of different communities throughout Japan. In the big cities, you get large numbers of developers because there's large consulting companies, a lot of software development happening there. But in the smaller areas of Japan, you get a very local flavor to the communities and the user groups, and there's large user group communities. But they don't always get the attention and the visibility which they would get normally if they were in a large hub like Tokyo. On this tour, we have Sebastian Daschner, who is a Java champion from Germany. He's presenting about cloud-native Java development. We have Kurt Pepperdine, who is a internationally known performance tuning guru. And lastly, we have David Delabase, who is a Java EE and WebLogic evangelist for Oracle. It's great that we share a common interest in motorcycling, and we're able to use that to spread a little bit of our passion about Java to the global user group.
Humanity is bound to change more in the next 20 years than in all of human history. We can't predict the changes. Every day becomes an invitation to prepare for the future we want to build. Highways without drivers. Education without classrooms. Healthcare without doctors. 2 billion jobs will come and go, freeing up talent for many new, unknown, burgeoning industries. The first hurricane may be stopped entirely by human intervention. It'll be common to use next-generation search engines to search the physical world. And basic computer programming will be considered a core skill required in most jobs. That's what the world ahead will look like. Where the world goes is up for debate, but how we prepare for it is not. Cloud computing, big data, analytics, artificial intelligence, the Internet of Things, and more. Oracle, the world's most complete cloud company, will be there.
I've been traveling around to a bunch of the Oracle Code events worldwide. We've done these across the US, Europe, and now Asia. We just finished Oracle Code Japan, which was an awesome event. We're on a motorcycle tour following that event, traveling across Japan, visiting different user groups. The reason why Oracle's reaching out to developers is the way people buy software, services, and products has really changed. Now, developers have a lot more control over the technologies they use, so we want to directly engage with developers, teach them about some new open source technologies, and then show them that those technologies which we're using run very well on the Oracle Cloud. One of the big advantages Oracle has is having a very large community. So by building on top of our stack, you're not only getting the Oracle products and services which run on our cloud technology, but you're also getting a lot of community support from folks in those open source technology communities. So there's over 300 Java user groups globally, Java user groups and the Oracle user groups. They run their own events, they talk about technologies, they help folks get up to speed on how they can use our cloud technologies and platforms, and you can be part of the community. Basically, we're traveling across Japan and stopping at a dozen user groups in between via motorcycle, so it's a very efficient way to hit up a bunch of different communities throughout Japan. In the big cities, you get large numbers of developers because there's large consulting companies, a lot of software development happening there. But in the smaller areas of Japan, you get a very local flavor to the communities and user groups, and there's large user group communities, but they don't always get the attention and the visibility which they would get normally if they were in a large hub like Tokyo. On this tour, we have Sebastian Daschner, who is a Java champion from Germany. He's presenting about cloud-native Java development. We have Kurt Pepperdine, who is a internationally known performance tuning guru. And lastly, we have David Delabase, who is a Java EE and WebLogic evangelist for Oracle. It's great that we share a common interest in motorcycling, and we're able to use that to spread a little bit of our passion about Java to the global user group.
Humanity is bound to change more in the next 20 years than in all of human history. We can't predict the changes. Every day becomes an invitation to prepare for the future we want to build. Highways without drivers. Education without classrooms. Healthcare without doctors. 2 billion jobs will come and go, freeing up talent for many new, unknown, burgeoning industries. The first hurricane may be stopped entirely by human intervention. It'll be common to use next-generation search engines to search the physical world. And basic computer programming will be considered a core skill required in most jobs. That's what the world ahead will look like. Where the world goes is up for debate, but how we prepare for it is not. Cloud computing, big data, analytics, artificial intelligence, the Internet of Things, and more. Oracle, the world's most complete cloud company, will be there.
I've been traveling around to a bunch of the Oracle Code events worldwide. We've done these across the US, Europe, and now Asia. We just finished Oracle Code Japan, which was an awesome event. We're on a motorcycle tour following that event, traveling across Japan, visiting different user groups. The reason why Oracle's reaching out to developers is the way people buy software, services, and products has really changed. Now, developers have a lot more control over the technologies they use, so we want to directly engage with developers, teach them about some new open source technologies, and then show them that those technologies which we're using run very well in the Oracle Cloud. One of the big advantages Oracle has is having a very large community. So by building on top of our stack, you're not only getting the Oracle products and services which run on our cloud technology, but you're also getting a lot of community support from folks in those open source technology communities. So there's over 300 Java user groups globally, Java user groups and the Oracle user groups. They run their own events, they talk about technologies, they help folks get up to speed on how they can use our cloud technologies and platforms, and you can be part of the community. Basically, we're traveling across Japan and stopping at a dozen user groups in between via motorcycle, so it's a very efficient way to hit up a bunch of different communities throughout Japan. In the big cities, you get large numbers of developers because there's large consulting companies, a lot of software development happening there. But in the smaller areas of Japan, you get a very local flavor to the communities and user groups, and there's large user group communities, but they don't always get the attention and the visibility which they would get normally if they were in a large hub like Tokyo. On this tour, we have Sebastian Daschner, who is a Java champion from Germany. He's presenting about cloud-native Java development. We have Kurt Pepperdine, who is a internationally known performance tuning guru. And lastly, we have David Delabase, who is a Java EE and WebLogic evangelist for Oracle. It's great that we share a common interest in motorcycling, and we're able to use that to spread a little bit of our passion about Java to the global user group.
Believe every human being is a potential coder.
Quizzical mind, somebody that likes to solve puzzles.
Someone who can work within a team.
I think you have to be quite meticulous.
You have to persevere.
Intelligent enough to understand the logic of the code.
Have empathy for their users.
The first thing is patience.
Likes to solve riddles.
A good coder is someone who can think through clearly and implement their idea into code.
10 years ago, we were coding for computers, but now everything is a computer.
A lot of the redundant and rudimentary stuff we do as a developer will be taken over by these automated processes.
Things like human brain interfaces and machine learning and neural networks.
Potentially a new language that doesn't even exist yet.
Still believe we have a bright future despite self-driving cars and artificial intelligence.
Interacting with a keyboard-less layout.
I think we're going to see a lot more voice interaction with devices.
Hopefully not computers coding themselves. This would be like, how it's called, the singularity, right?
I code because I love coding.
I code because I love, for me, it's like a brain puzzle.
Because I'm a builder, and I ran out of Lego bricks.
There's a lot of creative juices that flow when I write code.
Because I like making things, basically.
Coding is fun.
It's a fascinating, wide open field where you can do anything you absolutely want to do.
Having a problem that you turn into a solution through code is one of the most beautiful things in a job that I can imagine doing.
Welcome to Oracle Code Bangalore. My name's Stephen Chin. I run the Oracle Developer Community Group at, well, Oracle, of course. Very pleased to be able to announce the second time which we're running this event here in Bangalore. Was anyone fortunate enough to be here last year? Okay, excellent. Thanks very much for coming back again. We have a lot of great content today. We have sessions on machine learning, artificial intelligence, chatbots, AI, blockchain, databases, Java, lots of great technical content for you guys to enjoy today. Exciting demos out in the developer lounge, interviews going on all day today. And we also have a special guest to kick off and introduce the conference. I want to invite Gitu Bhatnagar to the stage. She's the Chief Marketing Officer of India. Gitu, welcome.
Thank you, Stephen. A very good morning to everyone here. Good. So all of you would know that Oracle has been working with developers ever since its existence, which is 4 decades now. As the pioneer of the database and gradual growth across all layers of technology, which is license or cloud, be it SaaS, PaaS, or infrastructure as a service, Oracle has been at the helm of innovation. Today, Oracle serves 430,000 customers in 175 countries. Closer home in India, we work with 15,000 customers across the public and private base. Additionally, Oracle globally works with 5 million registered members of the Oracle developer community, and supports 469 independent user communities in 97 countries. So if you look at it, this event, designed for developers, Oracle Code, will provide insights and practices for tackling development challenges and opportunities in the cloud. In Greek mythology, the torch symbolizes revolution and human achievement. We hope to inspire the same feeling among the coding community. If code is the light of the software industry, then the developer community is the torch. They go hand in hand. To recognize the community of developers, the people who are the baseline for everything digital we have in our lives today, we highlight that the Oracle is a coder-friendly company. And to inspire the next generation of developers, let us light the torch today.
Great, thank you very much, Gitu. Big round of applause. So today, the best way to get information about the sessions is to use the mobile application. You can download the Oracle Events application, go to the Oracle Code Bengaluru tab, find out the latest information about when the sessions are happening. We also encourage you to use Twitter. Tweet out to #OracleCode. We'll be following this from the @OracleDevs account, so you can also find the live interview streams on Oracle Code as well. And I want to introduce my special guest here. So this is the Now robot. He's an autonomous robot. Hi, Now. Hi, Now.
Hi, Stephen. How are you doing today?
Very good. So welcome to Oracle Code.
Wow, great to meet you all. I am Now, an autonomous robot who specializes in human interaction. Today I will be in the developer lounge and have some cool demos to show you that integrate with the Oracle Cloud Chatbot service. Please stop by and have a chat with me.
Can you tell us about the high tea?
It is great to see so many women developers and allies of women in the audience. Please join the Women in Technology High Tea this afternoon, where there will be a panel of inspirational women developers.
Can I come?
Yes, you can. Stephen, everyone here at Oracle Code is welcome to come to the High Tea, including men, women, and robots.
Thanks, Now.
Thanks for having me, and please enjoy the Oracle Code event today.
Okay, so that's Now Robot. You can see him in the developer lounge later. Thank you, Now. Okay, and without further ado, I'd like to introduce our keynote speaker. Very glad to have Pratik Patel joining us here on stage. Thank you very much for coming out here, man.
All right. Good morning, Bangalore. Thank you. Can't get started without a good morning. Right. Are you going to leave the robot on, Stephen? Okay.
Take him with
just
me.
Checking. So this morning I'm going to be talking about serverless in the Java ecosystem. And before we get started, just want to get an idea of how many people know what serverless is. Okay, so a few people. My question to you is, are you sure you know what it is? All right, so what we're going to do in this session is we're going to talk about serverless architecture, and what actually is serverless. We'll also do a demo using the FN project, and we'll talk about where we currently stand in terms of serverless architecture and what it means to developers. Okay, it's working. My name is Pratik Patel. I run a small technology startup in the city of Atlanta in the United States. I'm a Java champion and all these other things. So let's jump right into it and talk about what is serverless. Again, we'll go over the architecture. We'll also discuss the ecosystem in some detail. So first question is, what actually is serverless? This is something that is, unfortunately, is a very bad name. All right, so when we think of serverless, what is it that we're actually trying to understand? Well, what does the term actually mean, right? In a lot of ways, the name is actually not very good. So you probably have all seen this movie. This is Office Space, right? So it's not so much about destroying our servers, but there's a guy who's pretty big in the serverless space. His name is Kelsey Hightower. He works over at Google. And he tweeted this recently. He said, we asked 10 people to define serverless, and we got 10,000 different answers, right? So unfortunately, at this point in time, because serverless is such a new architecture, new tech, we haven't defined as a developer community what it actually means yet, right? So the responses to this tweet were hilarious, actually. So one of the responses was, right, again, the question is, we asked people to define serverless, and instead of one line of code, we got 10,000 containers, right? So this is obviously a joke against microservices and containers and Kubernetes and that entire ecosystem. And then the answers or the responses got even weirder, right? Serverless is GeoCities for the enterprise. Does anybody remember GeoCities from the late 80s or 90s? Some people, right. If you don't remember it, this is what it used to look like. It was basically a platform for publishing stupid web pages. And fortunately, somebody's archived it. But when we talk about serverless, yes, there are still servers. Obviously, we have to run our servers or our applications somewhere. Okay? So yes, there are servers, so it's not technically serverless, right? And what's the point of serverless? The idea for developers is that serverless is something that's both cheaper to run in terms of how much you have to pay your cloud provider to run your applications, but more importantly for me as a developer, it's about the ease of use and the ease of deployment. Right? Now I'll talk about this in a little more detail, but this current wave of microservices with containers and Kubernetes and Draft and Helm and Istio and this entire constellation of things around microservices is a bit overpowering sometimes. Because as a developer, what I want to do is I want to focus on writing applications and delivering features for my customers. I don't want to have to worry about how I'm going to deploy something or, you know, am I using the right version of Kubernetes and which cloud containers is running on, all these other questions. What I want to do, especially at a small company like mine, it doesn't matter if you're at a small company. If you're a big company, your goal as a developer is to build applications and deploy them as quickly as possible and as cheaply as possible to your customers, right? So serverless is also known as a couple of different things. I actually like these terms much better. So a couple of other terms that people use interchangeably with serverless is it's often referred to as FaaS, or functions as a service. And sometimes people also call them cloud functions. Okay? And we'll get into what this means in a few minutes. But again, we're trying to define what serverless actually means, and we'll get into some of the architectural models in just a second. But again, there are servers. The overall kind of metaphor behind serverless is that, and this is why it's called serverless, is that when we're developing, we don't really think in terms of servers. We just think in terms of applications or functions that we deploy somewhere. So what we're doing is we're removing the metaphor of the server from our developer kind of mindset. We just build something, we push a button, and it gets deployed somewhere. That's the idea. Okay? That's why the term is serverless. So again, it's running code without having to provision servers, without having to think about, am I running this in a Docker container, and how's it going to talk, and how do I set up the IP whitelist, and other things like that, right? We don't want to worry about these things as developers. We just want to write code, build features, and deploy them to our customers. So the idea behind serverless is we remove the metaphor of the server, and more importantly, we remove this concept of being a DevOps person. We just want to be a developer and write code. Okay? And the general idea behind serverless is that somebody else or something else or some kind of automation takes care of scalability for us, takes care of availability, and lots of other things, right? So typically when I deploy something in a serverless style, I don't think much about security around the operating system or the container that I'm running in and other things like that. I don't care about how I'm going to configure the network or load balancers. Someone else takes care of all this for me, so I can focus on writing my own code and delivering features to my customers, right? But along with this, so serverless is about 2 years old or so now, right? It was originally started by Amazon in what's known as Amazon Lambdas. Okay, but since then we've evolved, and the way that we think about serverless and an overall architectural model is also very different. So I would say that serverless, aside from being all the things I talked about, right, push button deployments, and you don't really worry about all these extraneous things that developers today have to worry about, it's also a new architectural model in terms of how we think of composing our application and building from a small application to a medium to a large size application. That's what we're going to focus on as we go through this. So one way to think about this is when the microcomputer came around, right, people had a IBM PC or something on their desktop, and you would install some software on it. You would install Excel or Lotus Notes or something. And that's how you would use, or that's how people use computing, right? So the shift that we've made over the last 15 to 20 years in terms of desktop computing or consumer computing is we now have software as a service, right? You can go to Google Sheets, for example, and use a spreadsheet directly from a web browser. If your people in your company use Salesforce, they don't install anything. They just open a web browser, they log into salesforce.com, and they have all the things that they may need to do for marketing and sales management and CRM and other things like that, right? So that's the shift that we've made in consumer computing over the last 20 years, is we've gone from having a microcomputer that has everything installed on it, or you install stuff on it, to you just open a web browser today, or your mobile application on your phone, and you can start using software as a service. Similarly, when we think of the enterprise, with what happened with AWS, right, and all these other cloud providers, is those were infrastructure as a service providers. And the shift that we're making today, and have been making for the last couple of years as developers, is we're going from that metaphor of infrastructure as a service, where you manage servers or virtual servers in the cloud yourself, to going completely serverless. So this is this jump that we're making today, right? And this is something that, in my opinion, is going to be very big in the next few years, especially if you're a developer, and especially because of the things I said. It's faster, easier, and also cheaper to run a utility in a serverless fashion rather than using infrastructure as a service, all right? So if we look at our typical pyramid, right, this is where we are today. What we have is, at the bottom we have our standard infrastructure as a service. See if this works. Let me stand over here. Okay. We have our infrastructure, right? So this is just basically your bare metal or virtual servers running on Oracle Cloud, IBM Cloud, Google Cloud, whatever it is, right? You basically rent a VPS, and then you choose what kind of platform you put on it. Typically, people put some kind of Linux or some kind of Linux derivation on top of that. And today, where we are with microservices, or this recent surge in microservices, we have our infrastructure, we have our operating system, which is the platform, and then we have containers, right? So these are our Docker containers, and we layer tools on top using containers, right? We use Docker, and then we might use Kubernetes to scale out, Istio for composition and other things like that. And then finally, at the very, very top, this is what we're concerned with as a developer. We're concerned with the applications that we have. Right? This is what we normally this is what we care about all the time. We care about, yes, we care about deployment, but we focus most of our time developing applications, right? That's where we spend the majority of our time, thinking about what our customers need from the requirements and other things that we get. Right? So we build applications. That's what things look like today in a non-serverless world. So what's happened today is, right, you can see I've used function as a service instead of serverless because I prefer this term. So we still have infrastructure at the bottom, platform and containers, but here, right underneath our application, we also have functions as a service. And this is how we build applications in a serverless style. So we sit on top of containers, right? And again, a lot of this is automated away, as we'll see in a few minutes. And we build our applications by composing functions. Right? So instead of building small little bits of code, we conceptually think at a coarser, higher level, right? Not all the way at the app level, but somewhere in between basic small units of code and your full application to construct apps. All right. So, went one slide too fast. Okay. So again, as a developer, I don't really care about all those things that are here at the bottom. Right? I don't care about platforms or infrastructure or even containers. Right? Yes, I do care about them, but what I want to focus on is I just want to focus on these two things at the top. As an application developer, right, whether you're building a web application, server-side application in Java, doing machine learning with Python, whatever it may be. What I care about are the two things that are at the top of this pyramid. I care about my applications, number one, and I build those applications using functions as a service or cloud functions. And we'll see what that looks like in just a few minutes to give you a better idea of where the future is heading and where we're moving in terms of a developer community. All right? All right, so it is a new architecture. What we do is we focus on building applications and all these infrastructure things like Docker and Kubernetes. We don't really care about these things anymore. Right? That's somebody else's job. Or maybe it's automated away. A lot of this has been made possible in the serverless world by automation, right? Because that's one of the things that developers are very good at. Well, good developers are good at. Right? Good developers, what do? If they have to do a task more than once, you automate it, right? So you don't have to keep doing it over and over manually. So we focus on building applications in a serverless architecture, and we don't worry so much about the infrastructure stuff. That's somebody else's job, or it's something that's handled by automation. Okay? So one of the things that we can do as we're building our own functions as a service is obviously we'll have to write our own business logic, our own functions as a service. Right? The code has to come from somewhere, and you have to write that. But as part of this model, we also have the ability to use or reuse functions that we've created and functions which are available for purchase or for free or whatever it may be. And we'll talk about the distinction between functions as a service and libraries in just a few minutes. We'll get to that in a sec. But let's think about what this actually means, right, in terms of architecture. The other core tenet of serverless architecture is that it is an event-driven type of model. Okay, so what is an event? There are all sorts of different events. The events can be almost anything. But it's the conceptual model around having small units of code that are triggered or fired by events of some kind. It could be an HTTP call. It could be something coming off a message queue. It could even be some kind of file system monitor that looks for something that changes in a file system or a trigger in a database or whatever it can be. It's some kind of event. That's the metaphor that we think about when we think in terms of serverless architecture. Right? So what are some fast events? I mentioned some already. Right? So we can have a message queue, HTTP call, file system or database monitor, inbound email, or even saying, OK Google, or hey Alexa, what's the weather today, right? Anything can be a trigger for a serverless function. It's not necessarily something that's very constrained, right? Something that evokes functions. So at this point, you might be thinking, OK, this sounds great. It's a new architectural model. I buy into this. But have we been doing this already? Have we been using serverless style or serverless architectural style programming already? And the short answer is you probably have. I know I have. So I'll give you an example. So this is a feature in our application. The application is a mobile app. But again, in serverless style architecture, the event can come from anywhere, and the event can be anything. In this case, the event or the initial trigger event is just a RESTful HTTP call, right? But what we do for this specific feature in our application, this is what we call an image translator. You basically, I'm in Bangalore. I don't speak or read the language here. I get a receipt that I have to file for expenses, right? So what I can do is I can take a picture of that, and our application goes into the cloud, hits our functions that we have, our serverless functions that we have in the cloud, or cloud functions, and it does these three things. It orchestrates these three different things. So first it does an image OCR, and so obviously it has to read this menu or this receipt or whatever it may be. So we do an image OCR first, and then we have to do a translation from whatever that language is into English so that the user or me knows what's going on that specific thing. And then we have our own business logic that we've wrapped inside of our own function as a service. So our startup is pretty good, but we're not so good that we wrote our own image OCR, right? Because this is something that's a very complex problem and would have taken us a long time to do. Same thing for translation, right? From translating from Hindi into English or French into English or whatever it may be, we didn't write our own translation service. What we do is we use cloud functions that already exist to do both of those things. And we weave them together, and we have our own function as a service that adds our proprietary business logic to complete this feature. So we actually have been doing this for years. So we rolled out this feature, I think, about 4 or 5 years ago. And we've been using functions as a service, and we didn't even know it. right? So we use image OCR, basically say, here's an image, go and read it for us and tell us what the results are. We take that, we feed it into another pre-existing cloud function that does translation of that OCR data, and then we have our own function as a service that takes those results, applies a proprietary algorithm to it to make the results better than just straight translation, right? So we've been doing functions as a service for a while, and we have all this running in a single instance, and it basically wakes up. The event is a HTTP call coming in with image data, and we get data out of it that shows the results, as you can see here on the bottom, right? So you can see that it's translated. Oop, this is going crazy. So you can see that it's translated from whatever the original language was into English, okay? So the short answer is that we probably, or you probably, have been actually already doing some kind of serverless computing or functions as a service or cloud functions already, okay? But now what we need to do as a developer community is understand how this fits into an overall model and how we can build all of our applications to take advantage of this easier and cheaper way of deploying and running applications in the cloud, right? So there are lots of cloud functions that are already available. If you use Twilio to send an SMS text message, you're using a cloud function. If you use Stripe or some other payment gateway like PayPal, you say, here's a credit card. This is how much I need to charge this customer. You're using a function as a service already, right? Et cetera, et cetera. Image resize, sending emails. So all these things already exist, and we're using them today already, right? So what's the next leap that we need to take? In terms of an architectural shift, what we do today is when we want to use some functionality that's not provided for us, what do we typically do? We reach for a library, right? Whatever the library is. Say we're parsing CSVs, or we need to do an OCR, a character recognition on an image. What we'll do, and again, it doesn't matter if you're doing this in Java or in Python or in .NET or any other language, right? We reach for a library and we say, okay, we need to do this thing. We're going to include this library in our application. We're going to use the API that the library provides us, and that will give us the functionality so that we don't need to write this, right? As developers, we've gotten really good at reusing things, and we do reuse today by libraries. So the architectural shift that we're making now is instead of importing a library into our application, what we want to do in a serverless-style architecture is we want to think, well, maybe we don't need a library to do this specific thing. Maybe what we do is we find a cloud function that already exists, or maybe my teammate over here wrote this other cloud function, for example, for doing authentication, right? Because in your company, not everybody is going to write an authentication algorithm or whatever, right? You have somebody in your company write it once, and then the other developers in the company will use that so that you don't have to reinvent the wheel 100 times. So instead of including a library to do authentication, right, what a lot of people do today is they prop up some kind of HTTP endpoint, and they say, this is the endpoint, this is what you invoke the endpoint with, and this is how you can authenticate, and you get some kind of token or cookie or OAuth or whatever it may be back, right? So this is the architectural shift that we have to make as developers when we start thinking in terms of architecting a serverless application. We don't think, okay, let's reach for this authentication library or for this library to do image recognition or whatever it may be. What we do is we think, let's see if there's a cloud function that I can use that I can pass the data to that will go and run this thing for me and give me the results, right? So this is the specific architectural shift that we have to make as developers. So when we think of a function as a service, at what level of granularity, how much code is in a single function as a service? The basics around this are kind of vague, but when we think of a function as a service, we think of it as being a small unit of work. It's not something that contains a whole feature necessarily. It contains one small thing or a couple of small things which are related, right? And they generally should be single purpose when we write a cloud function. Because the idea behind the cloud function is that aside from being small, it should also execute very quickly. It shouldn't take forever to run. And of course, when we say execute very quickly, exactly how long does that mean? The answer is it depends. If you're doing image OCR, it might take a second or two. But if you're doing something like authentication, it should be sub-second, maybe 100 or 200 milliseconds. It should be very fast. Because we want to weave this together or weave these cloud functions together to produce an overall application that may take much longer to execute. So your functions as a service should be small and should have a well-defined API. Also, right, aside from short running, your function as a service, your cloud function, should also be stateless. Right? So this is where people generally say, well, I can't, how do you build something if it's completely stateless? That doesn't mean that your application is stateless. It just means that that specific function as a service or cloud function is stateless. Right? But we obviously need to have state in our application. Because you have a user that comes to your website, for example, and for building something like a shopping or shopping cart application, you want to remember what the user has put into their cart as they navigate from page to page or look at different items. And then at the end, you want to calculate everything, do payments and all those kinds of things. So you do have to have state, but the function itself shouldn't have state. The state should be external to the function, because you don't necessarily know when the next call comes in from your user that it's going to land on that exact same instance of your function running in the cloud. So the function can reach into a database or something like Redis or whatever it may be, whatever you're using to store state, right? Again, it could be database, could be Redis, whatever, right? So you can reach into that and say, the users come back, here's their token, give me all the stuff that they put in their shopping cart so far, right? So state is there, but it's external to the function. Right? So this is one of the core tenets. Go grab state, it's there, but your function itself should be stateless, right? Which is a big difference than how we write web applications today. The other thing around functions as a service is we generally model them in two different ways, synchronous and asynchronous. Because there are certain cases where when you're building a function, you may say, you know what, I don't really want the result right now. I'm going to go do these other things for a bit. So go and run this function with this data, and then I'll come back at some point in the future and get the results. And there are several different reasons for doing that. Architecturally, you may say, I just don't need the data yet, or the user's doing something else. Or it may be that the function is doing some kind of long-running task, and you don't want to wait for it and block the user from moving ahead. Okay? So functions, cloud functions, can be both synchronous and asynchronous depending on the specific situation in which you wish to build them, how you wish to architect your specific application. Okay? So again, async is for long-running code. You get back an ID, and using that ID, you can come and get the results at some point in the future when you're ready to go and get them. Okay, so let's do a quick kind of demonstration of some of the fast implementations that are available in the Java space. Okay, and I believe after this session, there's a deep dive into the FN project, so they'll show you like exactly how some of this comes together. What I want to talk about is convey the idea or the concept of serverless and what it means architecturally. Okay? Oh, one thing to remember, let me go back to this slide. One thing to remember is that even though what I'm going to talk about is fast implementations in Java, the client can be anything. The client can be a web browser, right, JavaScript, or it could be a Python application running somewhere. It doesn't matter. As long as you define your endpoint in the appropriate way, and you make that public, and you have some documentation around it, the person calling it can be anyone. It doesn't have to be Java. All right. So the first one I want to talk about is the FN project. All right. And this is something that's sponsored by Oracle. It is completely open source. And again, there'll be a longer demonstration after my talk. Also, what's popular, this has been around for a bit longer, something called OpenWhisk. It's open source, and I believe it's an Apache project, or it's an incubator. But one of the nice things about OpenWhisk, as well as FN project, is that you don't have to build your functions in Java. You can also build them in JavaScript or Python or Go or whatever. So almost all these serverless frameworks support multiple languages that you can implement the actual functions with. So you're not constrained with necessarily just writing things in Java. Okay? So and the third one is Amazon Lambda, of course. So this is the one that is the oldest and also has been around for a while. It supports multiple things. But there are certain things with Amazon Lambda as developers that I've talked to don't really like. A lot of the stuff you have to do with Lambdas you have to do in the cloud. It's kind of difficult to do local development and other things like that, right? But they're working on solving those problems. So let's do a quick flyby of the FN project so that you're ready for the deep dive in the next one. So what we do is we do have to have Docker running on our laptop, and we fire up the FN server by doing FN start, and then when we want to create a new project, we say FN init, runtime, in this case we pick Java and we give it a name, and then we can just go and immediately execute it from this command line again using FN. So you have to install the FN project on your laptop or on your development machine, and you do have to have Docker running. It uses Docker underneath the hood. But all that stuff is kind of hidden from you through these command line utilities. And what does the specific Java implementation actually look like? It's pretty straightforward. So when you're writing these things, in this case you can see we just have one cloud function. It also generates a test for you. But if we look at the hello function.java, this is what it looks like. And what we care about is this specific thing here. Right? We say public string, so our interface is right here at the top. Handle request, and in this case we're just taking a string as an input and we're returning a string as an output. Right? But that input and output can be anything you want. It doesn't have to be something as simple as a string. It can be an array, some kind of JSON data structure, whatever you want, right? Whatever is appropriate for the specific application that you're building. Okay? So once we have this, what we can do is we can do FN run, which does the local execution for testing or for development or whatever, and just a local execution. But when we want to run it inside of the FN project server, we set up the registry. We tell the FN command line to deploy that specific application using this name, and then we can go list all the things that are deployed inside of that FN project server, which is just a Docker container running your code. Okay? So again, the folks coming on after me are going to do a deep dive of this, so I don't want to go too much into this, but this is how easy it is. And this is one of the great things about serverless development, in my opinion, is that it takes away a lot of the friction that we encounter when we want to build a project and we want to deploy it. Right? Again, as a developer, what I'm interested in is building great applications, building code, getting stuff out to market as quickly as possible for my customers, and as cheaply as possible as well. Right? So one of the other things that are included in the FN project is that it does have an embedded database for persistent storage. Right? Remember, we talked about how functions are supposed to be stateless. Where do you store that state? In the case of the FN project, it actually comes with the database built in. I typically tend to use a Redis store because it's an in-memory store that I can cluster very easily behind my functions. But the FN project comes with the store and also comes with the message queue so that you can do serialized executions of functions as you wish. Right? So these are all architectural things that come together that allow you to build a complete application inside of the FN project in a serverless style. Right? So a couple of other things that come with the FN project, they're building out something called FN Flow that allows you to orchestrate multiple function calls. Because if you remember, functions are supposed to do one thing and not a whole bunch of different things or a group of related things. So what we typically do, as you saw in the OCR example that I gave, is we call this function, we take that data, might do something with it, call this other function, call another function to compose a complete application. Right? So let's look at the orchestration bit very quickly. Right? So hopefully what this will do is this will give you an idea of what granularity you should be building your cloud functions or your serverless applications. Right? This is the approximate correct level of coarseness that your functions as a service should have. Okay? So, for example, we have something that we need to book flights and cancel flights. So we'll have a single serverless function that does both booking and cancellation of flights. Let's say that we need to book a car or cancel a car reservation. Similarly, we'll write a single serverless function that does that. And you can see we have a couple other things, hotel bookings, right, and emailing the final details to the actual user, et cetera, right? But this is the correct level of coarseness that we want to think about when we think of building stuff in a serverless architectural style. It's not super low level, right? So we're not saying, okay, let's take a flight, or I want to book a flight that has these specific details from these airports and blah, blah, blah. Yes, we pass that in, but the verbs that we use here are very simple. We have this function that has two endpoints, book and cancel. And that's about the level of granularity that you want to keep things when you're building stuff in a serverless architectural style. Okay. So for the FN project, you can deploy this on your own servers, or you can deploy it into the Oracle Cloud. And to make the friction even less, Oracle is going to be offering managed instances where you don't even have to set anything up. You basically just say, I want FN project server running somewhere in the cloud, and as you saw here, when we wanted to deploy this locally, we set up this FN registry, right? And we said, this is where we want to do the deployment. So in the future, what you'll do is you'll basically just use your registry name that's provided. And you can set this up on your own currently on any cloud provider. The FN project is open source. But the Holy Grail is having managed instances where I can just go to a website and say, I want an FN project deployment. Just click a button, it's set up, it gives you back a key, and that's all you have to do as a developer. You don't have to worry about setting up Docker or Kubernetes or Istio or Mesh or any of that other stuff. Basically, write your application, you push a button, or from the command line, you set something up, and it deploys it for you automatically. Okay, so let's do a quick comparison matrix between the different fast implementations which are out there. There's OpenWhisk, Project FN, OpenFast, Kubeless, Serverless Project. There's a bunch of these right now. So as you know, when tech takes off, or when a new type of tech takes off, a lot of people build implementations, and at this point in the serverless game, we're still very early on. So when we think of what Amazon offers and what the FN project and OpenWhisk and all these, they support multiple platforms, right? So if we want to look at a comparison matrix for this, unfortunately, the space is moving so fast, things change very rapidly. So for example, if you use Google Cloud currently supports cloud functions, but they only support writing them in JavaScript currently. They don't support writing them in any other language. AWS Lambdas can be written in Java, JavaScript, Go, Python, and a multitude of other platforms, right? But my point with this slide is that we don't really know where the space is going. We have an idea where it's going, but it's moving so rapidly that things are changing very quickly that we don't exactly know what the future holds 3 or 6 months from now. Yes, you can build serverless applications. The market is evolving very quickly currently. We have loads of serverless applications out there right now, so it's not something that you have to wait for, right? You don't have to think to yourself, well, we don't know what the future holds right now, but if you're building something with Java, you can use the FN project or you can use Amazon Lambdas, but you can't use Google Cloud Functions currently to do that. You will be in the future, is my guess, but all these things are evolving. The way we think about orchestration and security in the cloud is also evolving very quickly, okay? But that's one of the reasons I like serverless functions, is for me as an app developer, I can focus on exactly what I want to do to get an application out to my customer as quickly as possible, and I don't have to worry about security and deployment and all those other things around it, right? And it will just get better over time. So are we at a point where we're ready to destroy our servers, right? Maybe sold right now. Is this, right? Yes, this is great. We're currently building stuff using libraries, and we've already spent a lot of time and resources building out our microservices architecture, and we're starting to understand what microservices mean and how we should orchestrate microservices and how we should split our application into smaller microservices, right? And if you're doing that currently and you like it, by all means continue to do it. But if you want to leapfrog ahead of the microservices, looking into serverless architecture and writing stuff in a serverless style is probably, now's a great time to do it. You can get on board early, you can start thinking about how you can structure your project with a serverless architecture with some of the things I've given here, and we can get a better idea of how we build stuff in the future, right? So we're not quite ready to destroy our servers quite yet. But one of the things that I tell folks is that I've said that, yes, it is cheaper in terms of how much money I spend to host my application in the cloud using a serverless infrastructure or serverless architectural style. And the reason for that is all of these serverless providers, specifically if we talk about AWS and Amazon Lambdas, what they do is they only bill you for the exact amount of time that your function actually runs. For other cloud instances, so say you go and just get like a mini or large or whatever instance on AWS or Oracle Cloud or whatever. What do? You pay for every second that you own that server, right? So you pay monthly fee or weekly. Say you fire up the server and you're using infrastructure as a service. You pay for that 5 days or that 1 week or however much time that you are actually using and own that server. Whereas in the serverless world, again, because we're whittling everything down to such a small thing, you only pay for the exact amount of time that your app is actually executing. So let's say that your serverless function, right? We'll just make this a little bit simple. Let's say you have one serverless function. That serverless function takes 200 milliseconds to execute every time you call it. And you call it 1,000 times a day. You only pay 1,000 times 200 milliseconds of execution time. Okay? So a classic case study in this space is there's an online travel portal called Expedia. Does Expedia exist here in India? Okay, so you're familiar with Expedia. They basically took their infrastructure or their cloud costs from $6 to $7 million per month to about $500,000 to $600,000 by using a serverless architecture, right? Because again, you only pay for that small slice of time that your function is actually executing, and that's where the cost savings come in, okay? But as this slide says, as a developer, sometimes the actual cost of running something in the cloud doesn't really matter to me that much, right? If I'm Expedia and I'm spending $7 million, yes, it does, right? But for us, we maybe spend $100 to $200 per month on servers in the cloud at my startup, right? So it doesn't really mean a lot to me. What I really care about is how long does it take me to get a feature ready, out the door, and into the hands of my customers. It's the time to market that I really care about. And on top of that, the other thing, right, because developers are expensive, everybody in this room gets paid real money, right? It's the cost of development, the cost of the actual developer. For myself and the 3 developers who are on my team, how long does it take us to build a feature in terms of engineering time? Because engineering time is money, right? Having a developer working on something is money. That cost often is very large compared to the actual cost that I'm paying to have a server running in the cloud somewhere. So it's the time to market that I care about, and it's how long or how much time does it take, how many resources do I have to put into building out a feature. That's the other main thing I care about. Yes, I care about how much I pay for infrastructure costs, but that's the least of my concerns. Right, I care about those 2 other things more. Okay, so thank you for listening. I have some references here. The slides are available online, and I'll turn it back over to Stephen. Thanks, everybody.
Hey, thanks so much.
You got it.
So I would like to invite our next presenter on stage. We're going to have some presentations on chatbots, machine learning, some cool demos that you guys will get to enjoy. So Ravi Pinto, please join me. Oh, there you are.
How are you doing?
How are you doing?
Good.
I'm going to steal something from you.
Oh. Okay.
You don't need this.
All right.
Yeah.
I thought people might not know me, so.
You're more famous than you think.
Hi, good morning. It's always nice to see a full house to talk about some stuff that we are doing in Oracle. And thanks, Prateek, for taking us through that serverless bit. It was very enlightening. And we will be talking about some of the serverless stuff. So let me just get this on. All right, so we're going to do some stuff, but before I do that, I have to tell you that there are some things that I'm going to talk about which are going to happen in the future, okay? And therefore, whenever you're deciding or taking a technology decision, you must check what exactly, what status that particular service, for example, is. So in this particular case, I'll be talking about blockchain. Which is not yet available, but that's case in point. So you might be thinking, what exactly is Oracle doing with a developer event? I know that some of you were here in the last code. I did see hands go up. But, everybody tells us, you are a database company, right? Yes, we do build the best database in the world, but we also do a lot of stuff in the application development area. You may or may not be aware of it, and therefore, I just wanted to give you an idea of the stuff that we've been doing. These are some of the open source projects that we support, that we sponsor, that we contribute to, and we invite developers to join into these projects and contribute as well. And through all this, through all the interactions that we are having with customers, with developers, with partners worldwide, we see certain trends, and we want to share that information with you, get feedback from you, and also tell you what we are building in these areas which can be helpful or which you could leverage in your own application development, right? So these are the broad trends, that's serverless, there is the chatbots, how everything is moving to no ops. Prateek talked a little bit about it, and I'll just give you a bit of more idea on that. Blockchain, how many of you have heard about Bitcoin? Oh yeah, I did expect that. I should have actually asked how many of you have not heard of Bitcoin. So Bitcoin is powered by this underlying technology or concept called blockchain. And people are looking at how to implement blockchain in the context of a business application, and we'll actually be building something on that. So Prateek talked about this. I won't talk a lot, but serverless to me looks like Cinderella's fairy tale. How many of you do remember Cinderella's fairy tale? Oh, well, we did go to nursery together, right? So in Cinderella's fairy tale, the carriage that Cinderella is going to be taken to is created out of the pumpkin, right? And then when the party is over, that carriage goes away. Just like, it goes back into pumpkin. The serverless looks like that to me, right? So you want to invoke a service, and boom, the server is created for you on the fly. And as soon as that execution is done, that particular instance is destroyed. That's like Cinderella's fairy tale. But let's look at one other trend. What is this spawning? And Prateek talked about this. This is actually moving developers who were all the time had moved into DevOps to look at something called no ops. Okay? How many things can be automated, or how things are automated so that you do not spend time or your precious CPU cycles in doing something that probably should be taken care by automation, right? And therefore, if you're looking at serverless as one of the paradigms, what you're also looking at is this whole headache goes away of what VM instance you should pick up, how to run it, whether you should know Linux or not, et cetera, right? So that's the other trend that we see. Open source is the third trend that we'd want to talk about. And essentially, you would realize that all of us are consumers of open source, but there are projects that we sponsor. FN project is one of them. Oracle Jet is another one, which is a JavaScript based library that's again open source. You can build your applications using Oracle Jet. And if you are looking at what are the other projects that we do in containers, in Kubernetes, etc., you could go to our GitHub page, look at the projects, and if you're interested, you can join in and contribute over there. FN project is today one of the most contributed to projects that we are sponsoring. Okay. All right, let's go ahead. Now, that's the trend from the perspective of building application, and here's another trend, which sort of, makes me think, have we really progressed? I mean, 4,000 years ago, Egyptians were communicating with each other using sign languages or, these icons, and look what we are back at, right? We are back into emojis. So, however, that's on the lighter note, but on a more serious note, we do see trend of applications being built or front ends actually changing into chatbots, right? So you have this channel like WhatsApp, Messenger, WeChat, Line, etc., that people are more comfortable conversing with, and these are the channels that then are going and talking to applications, which is a totally different way of doing things. So generally, applications would mean go to the menu, select an item, a form comes up, enter data, and then you go ahead from there, right? The server processes that particular data that you've submitted. But in case of chatbot, and I'll show you a demo of this, you are conversing with the application. That's a very different paradigm that defines or that requires different skill sets, different way of thinking, how you are going to design application. So this is another trend that you should be aware of. I talked a little earlier about this. So a lot of businesses are not really interested in mining bitcoins or creating another currency, cryptocurrency. But as the frontiers of commerce and economy increases, as more and more businesses across borders are talking to each other without really knowing whom to trust as a central authority, blockchain becomes a very, very important technology for these parties to trust each other. Okay? And I'll illustrate this when we actually go into the demo that we'll talk about. And then, of course, I cannot but not talk about AI and ML, right? Machine learning, it's not that it's new. If you go back and look at the whole computing, whole computing area, AI and ML are something that were started back in 60s. This was one of the core research area for a lot of computer programmers that you and I probably know of. But it hadn't really gained traction, beyond the labs. And the reason for that is A, you need a very large data set to actually train the machine learning algorithms. That was not available, but today that is. We are generating data like tons of, tons or gigabytes every day. And the other thing was this computing power that you need. So you have a lot of data. You have an algorithm that needs to run on that data, so obviously you need a lot of computing power. And with cloud coming in, that's exactly what you have available now. So the ML, the machine learning, is going to be a trend that you should be aware of, you should look at, and you will see more and more applications, more and more services using them. We have an entire set of services that we are building, which we call autonomous, because one part of that autonomous is to learn from the way services are being invoked and how it can be optimized. So in fact, in our SaaS, we have something called adaptive intelligence. You interact with our SaaS application, it learns over a period of time, runs algorithms, and then gives you a more optimized way of interacting with that particular application. So this is an area that is definitely going to grow in the coming years. So what are we going to do? We are going to take some of these areas, so serverless, chatbots, and blockchain in this particular case, and we are going to create or show you a demo of how to create applications in the new world. Well, it's not actually new. Prateek said that he has already been running serverless for quite some time, so it's not new. We are still coding, we are still writing applications. But what we are going to show you is a paradigm, a different paradigm of building applications. So what are we going to do? We are going to do a buy and sell cars application, okay? And what does that mean? Is that we will show you interaction into this cycle by using chatbots. We are going to show you how this entire thing can be interacted with serverless to get you some data about the car being bought or sold, and then where do you store all this data in a non-reputable way, right? So here is someone who wants to sell a car, and obviously he does not have time to go into a website and start doing finding out what's a good value for his car. So what he is doing here is he is accessing the dealership via a chatbot, okay? So he's not going into website, typing URL, or doing Google for a dealership, a car dealership. He's just using the chatbot interface to say that he is interested in selling a car. Now, this is the second part, and the second part is that here is a developer who is using or who's created this chatbot interface for buying and selling cars, right? And that whole development is not really coding, okay? So we'll talk about how this particular chatbot is being built. And then this particular chatbot, when you are interacting with it, it's going to make calls into the functions to find out information about the car. Is the car, what the value of the car is, right? So there is a rating agency. Is the car involved in some criminal case, which, sort of brings the value down for the car. So that's what the cloud function is going to do. And then all the information about the actual trading would go into the blockchain. Because here, there are two dealerships which are interacting with each other. There is no central authority that will say, oh yeah, this transaction is okay. So they are trusting the technology, okay? When you sell the car, that's going to make an entry into blockchain. And when someone buys the car, that's going to make another entry into blockchain. And these will be non-reputable because the system ensures that the records cannot be tampered with, okay? All right, so having said that, this is an overall view, okay? And what we are going to do is show you the chat interface. Remember, this interface is very different than the UI interface that you usually use. That's going to do some stuff, so I'll show you in that demo. And then we have a cloud function that makes a call and finds out the rating, the information about the car. And if the person is interested, it goes, makes an entry into the blockchain, and then the same data is leveraged by the sell function. So with that, I will now, switch over to the demo, okay? So I'm going to, change the cable here. Give me a second. I'm going to hook up my phone. And I also hope that the demo gods are favorable to me. Yeah, I should probably say a prayer, So this is Facebook Messenger. How many of you are not using Facebook Messenger? Wow. Okay. Man. So what do you use? WhatsApp only? Interesting. Because if you're building bots, WhatsApp does not really allow you to, make a bot available. It's against their business or terms of, terms and conditions. So what we are going to do here is I've already been chatting, trying to sell my car. You can see that. So this is Bob's dealership, and this is the chat interface. So obviously, I'm going to be very, very polite and say hi. Okay, and well, I hope they're not. Okay, they're online. Well, it's always online, 24/7. So what do I want to do? I want to sell a car. Okay. Well, obviously they're happy because, naya bakra. And since they are looking for my number plate, I'm going to, yeah, you can say that I've been clicking a lot of photos. Oh yeah, there. So send this particular, license plate. Yeah, it's a California license plate. I do have, like moonlighting that I do in the US. Can you upload recent picture of your car? Yes, I can. I just snagged it from somewhere. Won't tell where. Okay, that gets uploaded. So if you remember Prateek's, presentation, he talked about OCR. You upload an image and OCR happens as a cloud function. So that's something that's happening over here as well. So what you see here is already information about the car, which says it's a Lexus so-and-so. And I'm going to go into, yes, I want some more detail. At this point in time, there's another cloud function that's being invoked, and that is essentially giving me some details about the car. Is this correct? Yes, it is correct. And what's the mileage on the car? So I'm going to give a pretty small number because this is a new car. 1100. Well, so here is the information, again, being pulled using a function, which says, here is what a particular rating agency is telling that the fair value of the car is. But you know what? We'll give you, $10,000 more because it's a new car. It's not really used much. And do you want to sell it? Obviously, yes. 10,000 ज़्यादा मिल रहा है. Why not? So, okay, so they're happy, and they're saying that they'll start off the documentation. So let's now go back. And I hope we are back into presentation. Okay. Probably, yeah. Okay, so how exactly did we create this particular interface? And if you're thinking that, we wrote a lot of code, well, you're wrong. We did not write a lot of code, okay? What we did do was we defined what is called as an intent. So a chatbot is always going to do a certain set of activities, which are called intents. And those intents, if you see over here, is written as sell car and buy car. Those are the intents. Those are the things that the bot will understand, will process for you, right? Now, when someone says, or someone has the intention of selling car, what is the conversation that they are going to do with the bot? That is what you see in the examples, okay? There are certain utterances that this is what the user is going to say. And by the way, we also support NLP, right? Natural language processing, which means that even if you were to give, sort of different, different values. So instead of sell car, you're saying sell Lexus or buy Lexus. It will understand that you essentially want to sell, a Lexus car. So that is what's being written over here, and what you see on my left-hand side, your right-hand side, is a testing panel that allows you to find out, given a conversation, is the intention being correctly found out, right? Is the bot able to figure out what the intention is? So there is, I want to make dollars off my Lexus. Now the bot is confused, okay? The bot is not sure whether you want to sell or you want to buy. And what you can do at this point in time is, out of the two intents that are there, which is showing almost same confidence level, you can select one of them and say add example, and that will become something that the bot learns using the trainers that we have within this particular bot framework. Okay? So essentially then, whenever you say, I want to make dollars from my Lexus or off my Lexus, it's going to understand that you want to sell a car. Okay? So we've seen the chatbot interaction. What we'll do now is look at the serverless part, and for this, I will call upon Shiva to come and talk about the serverless bit. Shiva?
Thank you. Thank you, Ravi.
Welcome.
So, bunch of thanks to Prateek for reducing majority of the introduction part. So, FN project, as you mentioned, put it back. FN project is an open source project, Apache 2.2 license, and it is completely baseline on Docker containers. And one good part is you can run on your laptops, you can run on any cloud or any of your servers on premises. And another important thing is Oracle independently monitors this, but we have a representation in Cloud Native Computing Foundation for a FN project. What is a function? Before that, Prateek introduced functions as a service and serverless computing both. Serverless computing, I don't want to give 10,000 definitions, as you mentioned. There are it's a category of cloud services that abstracts much of the operations things, infrastructure operations things, deploying the server, provisioning of the server, scaling of the server, patching of the server, etc. So probably from DevOps to NoOps, what Ravi was mentioning it, part of it. And functions as a service is especially the compute portion in the infrastructure within the serverless architecture. And function, typically in a mathematical term, right, it's a piece of code which accepts multiple inputs and which can give multiple outputs. Probably with a disclaimer over there that one input at any point in time maps to one of the outputs. Now, in FN project, couple of components what he introduced, Pratik. Typically, there will be a server component, FN server, which typically process all the function calls. And within the architecture, you could see multiple other components as well. There will be a queue if you want to invoke functions in asynchronous fashion. All the function requests will be uploaded to the queue, and there will be a repository which builds a link between the function versus where the function code base or an image is available. There's a repository and a registry where your actual images of your Docker are going to lie. There are other components, probably we can dig more. And one of the component that introduced was FN flow. Okay, we have multiple functions defined, but to build applications out of the functions, we need a different programming model altogether that can stitch each of these functions and deliver an application to that. So when he showed a travel application, right, we have a booking a car, booking a flight, booking a hotel, etc., everything. So individual functions, they are self-sufficient functions. Now I wanted to knit each other to give you a feel of an application. So that is where FN flow is giving us an opportunity to do the composition of individual functions and delivering an application for that. Right. In this particular use case, you can look at my chatbot interface is going to invoke a function to sell a car. So that is going to be one of the top level functions that chatbot is going to invoke. But my composition is something like that. Before invoking the blockchain service, my composition is splitted with a function flow architecture in multi-dimension here. Initially, my root function is going to call Carfax to get more details about the car. If I have multiple cars, it has to emit the details for multiple cars. Then I want you to do individual criminal lookup functions. Means whether this particular car has any background of accidents or any kind of illegal activities that got involved over here. So FBI lookup and international lookup, two different functions are there. Now FN flow is completely developed with the Java API, and especially in Java 8 onwards, we have a complete stage API. We can leverage that. FN flow architecture leverages that complete stage API to give a CLI or SDK programming interface for developers. So you can see the invoke function where the future flow is the root flow is going to be invoked with a particular thing, and that composes multiple things. Again, it composes Carfax report and criminal lookup, and which has a combination of FBI and international lookup functions. When it completes, it goes to blockchain. These all putting under one code base. You can see the code base here. I'm just defining a flow initially. That flow is going to invoke a function called process a car. If I have multiple cars, I'm going to process individual cars. Means I leverage Java threads over there. Then I wanted to compose Carfax and criminal lookup. And criminal lookup, again, it has two different functions, international and FBI. Once everything is done, I'm going to finish the flow or invoke the other component. So I'm going to give a small demonstration of a simple hello world function that Pratik has shown in the PowerPoint, and later I will show the demonstration of FN flow as well. Okay, again, small prayer goes to the demo gods. So I just started FN server here. I just pressed, I just pre-populated a couple of things to save the time here. So I just pre-populated the server start part here, fn start. Then typically what I do here is create a small function here. I'm going to initiate with a runtime of any programming language. I can go, I can use Go language or Java language or Node language or anything. I'm going to give a name for this function, Oracle code Bengaluru function. Now you can see it has created a folder called Oracle code Bengaluru function with a runtime Java, and a complete boilerplate template has been created now. So I'm going to just getting into the folder over here. Just see this. It has a function ML file and a pom.xml file. Especially for Java, if I need to package something, I'm going to leverage here the Maven package manager. So pom.xml file is being created here by default, and a structure of your unit test cases with a JUnit and a code base with a simple hello function has been created. Now, if you want to see what is mentioned in this code base, now you can just see here what is it mentioned. Hello function, which has a method called handle request, which is taking this particular method is going to be called when a function is going to invoke, and I need to mention about this in the descriptor file. So whenever a function call comes, invoke this particular function. If there is no input, I just get hello world, otherwise I'll get whatever the parameter I'm going to give it. And previously mentioned that function retrieves, expects the input in a typical stdin format. And I can pipe any of the stdin to call the functions, and it emits std out and any errors that goes to std error. Now, another thing is ML file. Just see the ML file, what it is mentioned. This is my function name, version, runtime is this, command is invoke handle request here. This is what is going to be invoked every time. I have two different images here, build image and run image. Typically when you compile your code base, be it any language, Java or Go or any language, right, you need the complete set of libraries. But during the runtime, you can skim it down to a few libraries. So typically we also follow, during the build of this particular function, we use a different image, but when you run it, we load a different image. Now to run this function, typically I can use fn run. So it is going to build an image and invoke a function. Now you can see I got the response here, hello world. I'm just invoking locally. Now if I want to give an input to this, so I can do a simple piping here, Bengaluru, fn run. It's going to create the image again and give me the response, hello Bengaluru. So what if I wanted to register this function with my fn server so that the external component, my chatbot, can talk to this? This is pretty simple, fn deploy. I need to map this function against a particular name. One application can hold multiple functions together. I'm going to give a respective context path when I'm invoking it. I'm going to give Oracle code Bengaluru application. And where do I want to register this? I'm running my fn server locally here. So I just keep local here just to save the time. Now, my function image is being mapped and an entry is created in my repository. Whenever I make a call to this, I'm going to get an entry from my repository, and that shows the link to the registry where my Docker image is available. Okay. Typically, if you want to see how this particular Docker image is being created, I can run this with a verbose. You can see here. It is kickstarting the creation of the Docker and invoking the function, and my Docker goes down immediately. Similarly, now I have registered. I can call this with my CLI directly. Oracle code Bangalore application, and with a context root is Oracle code Bangalore function. I can directly call this. I'm getting the response. So similarly, piping and all, etc., I can do it. But if my chatbot wanted to do the invocation, typically it expects a REST API. It may not use the CLI. I don't need to install the CLI over there. So in that case, I can typically do a curling. HTTP :localhost. This is where I have registered, and my FN server is running at 8080 port. And working code Bangalore application / working code Bangalore function. I can just make a call. I can get the response. This is how chatbot is going to get integrated with my functions here. Now let me move to another area where I wanted to show you a bigger picture of composing multiple functions and calling this in our use case. I have a code base here. You can see it. I have a Carfax function. I have get car function. Probably multiple cars are there for selling. I can fetch it, multiple cars, and find Carfax report for individual functions, right? And have a criminal lookup for multiple cars individually. So I can do that. I have a flow component, another function, which is going to be my entry point. Kickstarting this, this flow component is going to fetch all the cars and individually execute getting the Carfax report and criminal lookups, etc. Okay, now what I have done is I just started this. Within my start script, I just started already. All 4 different functions are running already here. What is there in this start, if you want to have a look at? Yes, I'm starting individual components. Docker images, I'm just running it. Once all these applications are running, now I'm deploying all the applications. Each and every application is nothing but a function over here. It is deployed and an API is exposed out. You can see ByCar is a function, Carfax is a function, criminal lookup is a function, and a flow component is another function. This function is going to call these rest of the 3 functions, right? Just to save the time, I just pre-populated it. Okay. Now, if you want to really see all the functions are running, you can see here. My FN server is running. I have a flow server, and these particular functions are being already registered. Now I can call them. I'm going to call a function call. I wrapped all these functions under one application name, Oracle code. Now the flow is the function that is going to kickstart rest of the functions. Now while kicking this, right, I have a user interface here that depicts the invocation of this. Now we can see get cars. In get cars, I'm going to get multiple cars. So 2 cars are there, the 4 and 7. This is what Java threads, you can see it. For individual function calls, a new thread is coming. 2 cars are there, so individual cars are being processed now. The first car, I'm getting the Carfax and criminal lookup. Second car for Carfax and criminal lookup. You can see it. So at the end, once it is done, it is going to invoke, it's going to combine all the reports together and invoke the appropriate blockchain API. Now, I wanted to see what happened when I invoked it. Let me just zoom down so that I can see it. Get cars. When I invoke get cars, it returned me 2 different, okay, it is zoom. I hope you can see it. 2 different license plate numbers. 2 cars are there for selling. Okay, and it's going to, this has been invoked from a main call. Now I'll just go up pick up one of the cars that are being processed and Carfax report of the respective one. Now you can see the flow here. How this complete stage API is being called. The main call, get cars, for the first car, then apply, then compose. I'm getting into the processing the car, this particular one. Okay, then compose and generating a Carfax report for this one. These are the functions are being called by FNflow API. Okay, and respective execution times, etc., everything can be seen here. This is pretty much FNflow. So this resembles one of the design patterns in microservices world called Saga pattern. You could correlate with the same thing. Wherever you can't make a two-phase commit approach within a transaction, right? I wanted to book a car, hotel, and flight all together. If something goes wrong, I wanted to cancel entire itinerary. So for that, I have to define my rollback mechanism or a compensation APIs. So book car, cancel car, book hotel, cancel hotel. So because I can't do a database transaction of two-phase commit over there. So this Saga pattern calls the respective thing in an exceptional cases. This is what we are going to do. Okay. So if you want to see the code base of the flow, you can see here. Cat rc what I have done, main flow function. Yes. This is whatever it is being depicted in the slides. Get cars, then iterate over each car and run the process car. So for each car, I'm going to invoke the function here. You can see process car, process car for each car. Okay. This is how it is. Hope this is useful. Over to you, Ravi.
Thanks, Shiva. Thanks for that. All right, so what we'll do now is look at, now that the serverless has been shown to you, what we are going to see is how this entire information about transactions is being managed in the blockchain, right? So, and we are specifically calling this as permissioned blockchain because this is not like Bitcoin where anybody and everybody who knows how to access the Bitcoin API or use the Bitcoin API via wallets, etc., can go and look at all the records, right? So businesses do not want other people to come and look at the records of the transaction. They want to give access to specific people who can look at these transactions and then say, okay, we want to do a next transaction. So that's where the entire blockchain bit comes in. And what specifically blockchain is all about, if I go next, is there are three things that I wanted to sort of understand. First of all, every participant in a blockchain, so you set up a blockchain network where there are participants, every participant keeps what is called as their view of the world, which is a ledger, and that ledger has all the transactions, right, encoded. The other thing is these records are, copied over to every ledger in near real time, okay? And there is a consensus mechanism by which you order the transactions, okay? So there is no, proof of work like in Bitcoin, which is done, which is why we talk about Bitcoin mining and, a lot of computing being put to just achieve that, just achieve the ordering. But here, what we do is we use different consensus mechanisms to get the record ordered into the ledger as quickly as possible. And the most important part that I have been, I want to again emphasize on is when you're building applications which has parties that do not really trust each other, or do not have a central authority which they can go to. So for example, what I mean by that, you look at the banks in India, right? The banks in India have Reserve Bank of India as a central authority which, lays down all the rules, regulations, and also enables the banks to trust each other. But let's say, there is a shipping company in US and a shipping company in India. How do they trust? What do they go to? Yes, there is an international maritime organization, but do they really manage, what's the reputation of the shipper in India versus what's the reputation of shipper in the US? So what you do is you set up as a logistics company, you can set up a blockchain, a business network, where these parties can then do transaction. So we are seeing a lot of use cases, and you might have heard of blockchain earlier being proof of concept, concept that hasn't really got off the ground. But we are seeing a lot interest now, more serious interest, people collaborating and coming together to build various blockchain networks. We are actually doing some POCs here in India as well. And what exactly are we going to launch when we launch the blockchain service? So the blockchain service is based on Hyperledger Fabric. Okay, we have joined the Linux Foundation and specifically the Hyperledger Fabric project as a contributor. And what we are going to do when you have the service, the managed service, is each of the participants is essentially called a node. And these nodes are going to have the view of the world, their view of the world, which is the distributed ledger. And you will have an ability to define something called as the smart contract or chain code. Now, this is the code that you write to enforce certain rules and regulations, so to say. Just as RBI does it for the banks in India, you would use the smart contract to enforce certain business rules on the transactions that are happening. And then we have the ordering service, like I talked about earlier, to decide how the records are to be ordered. Let me go a little closer. And then we have an onboarding service. So when you get the participants, a membership service, when you get the participants, now these participants need to have certain security credentials, right? At least they need to give us or give wherever the business network is being set up, their digital certificate so that that sort of trust can be set up. So there is a membership service to onboard participants. And then there's a REST proxy. So you saw the cloud function invoking blockchain. That is via the REST proxy that's been made available. If you currently look at Hyperledger Fabric, it allows you to interact via gRPC. So you have to write code which is gRPC compliant. But the other way to do is use the REST proxy. So you can write code in any language that supports REST as a paradigm and interact with the blockchain. And then there is an admin console which gives you an overall view of what transaction, what is the business network, who are the peers, who are interacting with whom, etc. Okay? So let me quickly now jump into, so this is just to tell you, as a developer, what you would do, which is essentially code the smart code. And this is how the smart code sort of looks like. I won't go into detail. This is Golang that is being shown over here that Hyperledger Fabric supports. Recently, Hyperledger 1.1 has been released that supports Node.js as the smart contract language as well, right? So, so you will have that option. I will quickly show you the, okay, I need to go off the, let me come out and switch over to the browser. Okay. All right. Okay. So here is the browser, and essentially I'm looking at the admin console, and I also have to look like this because I can't really see it over here right now. But if you look at the dashboard, it essentially tells you that there are 3 organizations which are part of this network. There are 2 peers, which are the 2 dealerships that are interacting in buying and selling cars. One orderer, there are channels set up. So channels is how interactions between the parties happen. And what I can do is go into some of those details. So I can show you the network over here. And this is how the network is. Those are the three peers or three transacting companies. Here are the peers that are working on behalf of that. And we can also see a list of those. Okay. Okay. These are the lists, right? So these are the dealers, and this is the auto company. We can specifically go into channels, or rather into chain code. So there is one chain code that's been installed, and that chain code is essentially running on over here on the peers. So, sorry, here's the version. And you can see on what it has been, it's been installed on a channel. It's also been installed on the two peers which are interacting in this particular blockchain. Just to show you, let's not go here, but here. So we've been talking about, these cars that are being bought and sold. So here is an example which is essentially saying that if you want to trace a record for a particular car, you can just go in. So this is using the REST proxy to invoke details about transactions. What you see over here is the detail that you saw in the chatbot when we asked for more details about the car. And what you see on over here is the detail of what transactions could have happened. So if I just scroll to this side, which is today, you can see there is a transfer that has happened, right? So I can also go, so this is right now 5 bar or 6 bar 1 to 3, right? No, 5 bar 1 to 3. Let me just copy that. And what I'm going to do, it's currently with John's dealership. I'm going to transfer it. So we'll log in as John's dealership. Okay, I hope I've got that correct. Yeah, okay. So what we are going to do, oh, no, that's wrong. See, this application is pretty finicky, so I have to get that just right. So JONS, capital D, and we'll log in. Okay. So we are going to put that in over here, and the new owner is Bob's dealership. Okay. And we transfer the vehicle, right? So it shows return code as success. Let's go back to trace and do the query again. So I'm not even sure. Yeah. So you see the owner is now Bob's dealership. And if I go and scroll this up, I can come right at the end of this, and you will see that there are 2 transfers now, right? So this is essentially the 2 records of the transfer that has been initiated. Okay, so let's just go back. All right. So what you saw is essentially the blockchain being used for keeping track of these transactions. And how you could have parties which are not really trusting each other to still do transactions. Now, this, what you saw today, the chatbot, the serverless, and the blockchain, is all part of the application development stack that we have in the Oracle Cloud. And there are a lot of other services that you can leverage to build your application or to have your application integrate with other applications or other services. And you can see whether it's the data management services or the applications that you want to build, hosted on WebLogic in the cloud, or run plain Java, PHP, Ruby, Python, etc. We have the hosting platform for all these. We can run Docker for you. We are coming up with a managed Docker and Kubernetes service that will be soon available. You saw the FN project. We will have a managed service around FN as well. That's coming out soon as well, right? So we have been, if you've not heard about Oracle Cloud, we have been getting or focused on customers who have already been our customers on-prem and want to move over to cloud. But we are also working with a lot of startups, and you can sort of meet the Startup Accelerator folks that we have here. And with that, I sort of bring close to this presentation, except one thing. I did sell the car, right? So I'm going to show you the buying of the car using the chatbot again. And you are going to discover something that is very interesting. So give me a couple of minutes more. Okay, yeah. So you remember this number, right? 385K, right? That's what the dealership told me it'll give me. And actually what I'm going to do now is, so I want to buy the car, right? Okay, so welcome, yeah, I want to buy car, right? So, well, there are some cars available here. There's an Audi, there's a Cadillac, there's a BMW. Well, I'm not interested in any one of these. I want to buy a Lexus. So you remember, the bot builder, right? So now what it's doing here, interestingly, is it's telling me that there are no Lexuses that they have, okay? But they will check in the dealer network and essentially going into the blockchain and querying via the functions if there are cars available, which is a Lexus. And, well, they do find one, which I had sold earlier. So they show me this Lexus, and yes, I'm interested in more details. And the same details are over here. So would you like to purchase? Yes, I'm interested in purchasing. Well, tell you what. You did see the number, right? How two, parties who are not trusting each other still come up with a number, right? I hope you enjoyed this. Thank you very much for being a wonderful audience. Thanks. Stephen, back to you.
Thanks so much, Ravi. Okay, so hopefully you guys enjoyed some of the presentations. I'm going to describe some of the activities going on here today. First of all, we invite you to attend the Zip Labs. These are hands-on workshops. We're going to be giving out a prize to the person who completes the most Zip Labs successfully first for the day. You can find those in the back of the developer lounge, so just go through the glass doors. Also, we are very happy to have engagement, as you heard from Now earlier, on women in technology. So later today in the schedule, we have a women's high tea. This is open to all attendees, women, allies of women, robots. So everyone is welcome to join. We have a great technology panel that's being run, and also some great speakers. And I also highlighted some of the women speakers on the agenda here. Also, we want to thank all of our Oracle Code 2018 sponsors. They're the folks who have made this possible. So very glad to have different companies sponsoring us from around the world. And as you guys know, Java 10 was released at Oracle Code. We actually made the announcement at Oracle Code Chicago. So if you haven't already, download Java 10, check it out. The developer portal, developer.oracle.com, the same place where you registered for the site, is a great place to get more information about some of our developer programs. We have articles, videos, other great information about there. We're also going to be publishing a new tour page soon to go over some of our Oracle developer tours globally. And then here's a quick preview of the schedule for today. Again, use the mobile application for the schedule. The website also works good on mobile devices. And that'll let you know when all the sessions, the hands-on labs, the high tea, and other activities are going on today. Finally, I want to announce that our social team is doing a Twitter Hangman contest. So when you exit the keynote, they'll be doing a social Hangman contest. Follow @Oracle_India to play along. You can tweet your answers with #OracleCode and then mention @OracleIndia. And this will start during the coffee break, which is upcoming. So, participate. They have some cool questions to answer, and this way you can be active with our local PR team. So, thanks everybody. I hope you enjoy the rest of today at Oracle Code Bengaluru, and please enjoy.
I've been traveling around to a bunch of the Oracle Code events worldwide. We've done these across the US, Europe, and now Asia. We just finished Oracle Code Japan, which was an awesome event. We're on a motorcycle tour following that event, traveling across Japan, visiting different user groups. The reason why Oracle's reaching out to developers is the way people buy software, services, and products has really changed. Now, developers have a lot more control over the technologies they use, so we want to directly engage with developers, teach them about some new open source technologies, and then show them that those technologies which we're using run very well on the Oracle Cloud. One of the big advantages Oracle has is having a very large community. So by building on top of our stack, you're not only getting the Oracle products and services which run on our cloud technology, but you're also getting a lot of community support from folks in those open source technology communities.